Introduction to lists in Python. Lists are fundamental data structures in Python. A list is an ordered collection of items separated by commas and enclosed in square brackets. Lists can contain elements of different data types such as numbers, strings, or even other lists. Creating a list. Lists can be created by assigning a sequence of values to a variable using square brackets. Example, my underscore list equals square bracket 1, 2, 3, 4, 5 and close square bracket. Lists can also be created using the lists small bracket constructor. Accessing list elements. Individual elements in a list can be accessed using indexing. Indexing starts at 0. So the first element is at index 0, the second at index 1 and so on. Example, my underscore list equals square bracket 1, 2, 3, 4, 5, my underscore list square bracket 2 will return 3. Modifying list elements. List elements can be modified by assigning new values to specific indices. Example, my underscore list equal square bracket 1, 2, 3, 4, 5, my underscore list of 2 equals 10 will change the third element to 10. Lists are mutable, meaning they can be changed after creation. List slicing. List slicing allows us to extract a portion of a list. Syntax list underscore name square bracket start underscore index end index step size. Example, my list equals 1, 2, 3, 4, my list 1 is to 4 will return 2, 3, 4. Adding elements to a list. Elements can be added to a list using the append method. Example, my list equals 1, 2, 3. My list dot append 4 will add 4 to the end of the list. Elements can also be inserted at a specific index using the insert method. Removing elements from a list. Elements can be removed from a list using the remove method. Example, my list equals 1, 2, 3, 4, 5. My list dot remove 3 will remove the element with value 3. Elements can also be removed by using the del keyword or POP method. List methods. Lists have built-in methods that allow the various operations. Some common methods include sort, reverse, count, index. These methods provide flexibility and convenience when working with lists. List operations. List can be concatenated using the plus operator. Example, list 1 equals 1, 2, 3. List 2 equals 4, 5, 6. List 3 equals list 1 plus list 2 will result in 1, 2, 3, 4, 5, 6. List membership. We can check if an element is present in a list using the in keyword. Example, my list equals 1, 2, 3, 4, 5, 3 in my list will return true. The not in keyword is used to check if an element is not present in a list. List length. The length function returns the number of elements in a list. Example, my list equals 1, 2, 3, 4, 5, len of my list will return 5. It is a useful function to determine the size of a list. List operation summary. Lists in Python have a wide range of operations to manipulate and access their elements. Understanding and utilizing these operations can greatly simplify coding tasks. Lists provide a flexible and efficient way to work with collections of data. Advantages of lists. Lists are mutable, meaning they can be changed after creation. Lists can store elements of different data types. Lists have built-in methods for various operations, reducing the need for additional code. Limitations of lists. Lists can be slower when dealing with large amounts of data due to their dynamic nature. Lists can consume more memory compared to other data structures like tuples. Lists are not suitable for scenarios where immutability or constant time operations are required. Best practices. Use meaningful variables names to enhance code readability. Avoid using reserved keywords as variable names. Utilize list comprehensions to create new lists efficiently. Use cases. Lists are commonly used for sorting and manipulating collections of data. They are useful for tasks such as filters, sorting, and transforming data. Lists can be employed in various domains, including data analysis, web development, and scientific computing. Thank you for watching my video.